let's look at a couple of rules that will help us write numbers in surd form. A surd is a square root that does not have an exact value, for example the square root of 3. There are two rules we can use to help us simplify surds. The first one is that if we have the square root of a number that's a times b, we can write that as the square root of a multiplied by the square root of b. Likewise, if we take the square root of m over n, we could rewrite that as the square root of m divided by the square root of n. So those two rules we've just seen might not necessarily seem as though they're going to be that helpful, but when it comes to having numbers in our questions, they do prove very useful. And if we look at this first example, it asks us to write the square root of 80 in the form k root 5. Now the clue here is in the question. They've told us they want a 5 in that square root sign. So we need to break down the 80 in that original question into something times 5. And when we break that down, hopefully that something we find is going to be a square number. So let's look at the square root of 80 and think of two numbers, one of which is 5, that we can rewrite into giving us 80 when we multiply them together. If I think about it, what times 5 gives me 80? 16. So all I've done is rewrite 80 as 16 times 5. Why did I do that? Well, because they told me they wanted that 5 in the square root. Now what we notice here is that 16 is a square number. And using that first rule, the square root of 16 times 5 is the same as the square root of 16 times the square root of 5. Now we've separated them, we can work out the square root of 16 and give that a value of 4. So our final answer would be 4 root 5. And if they actually asked us what k was, we could write that k equals 4 in this particular question. If we have a look at another one, let's write the root of 98 in the form k root 2. So remember, the clue is in the question. When we break down 98, they want us to write it as the square root of something multiplied by 2. Think about what that something is. 49. So once we've rewritten it, we can then separate them out to give us the square root of 49 multiplied by the square root of 2, which gives us a final answer of 7 root 2. So in this particular question, k had a value of 7. So now we've seen how to simplify surds, we'll look at a question that involves us being able to do that. First one up here, multiplying out two brackets that contain surds within them. Now we know how to multiply out brackets. In this case, we've got the square root of 5 plus 2 multiplied by the square root of 5 subtract 4. So when I multiply out these two brackets, I'm going to use the FOIL method. Remember, first, outside, inside and last. So I'm going to do first of all my first terms, root 5 times root 5, and you should all be aware of this very important fact. The square root of 5 times the square root of 5 gives me an answer of 5. Two square roots with the same number in them gives you that number when you multiply them together, as the squared and the square root would cancel each other out. Square root of 5 multiplied by minus 4, my two outside terms, gives me minus 4 root 5. Two lots of root 5, my inside terms, plus 2 root 5. And finally my two last terms, 2 times minus 4, gives me minus 8. Now I can simplify this because I have some like terms that I can collect together. For example, 5 subtract 8 gives me an answer of minus 3. And minus 4 root 5 plus 2 root 5 gives me negative 2 root 5. Now you notice in the question it asks you to write it in the form p plus q root r. Now, whenever the question asks you to do that, what it wants is a constant, a whole number here, and then your surd following afterwards. If they wanted to know the values of P, Q and R in particular in this question, so P would be -3, Q would be -2, and R would be 5. It's important not to be put off in the question when they write it in the form P plus Q root R, because all that is the simplified surd form that you get from multiplying out the two brackets. Okay, let's look at another example of multiplying out and simplifying. In this question, they ask us again to write it in the form P plus Q root R, the expansion of √3 minus 1 all squared. Now, the big mistake people make on this question is that they just square the √3 and square the -1. But what you must realise is that √3 minus 1 squared is actually √3 minus 1 times √3 minus 1. If you don't write those two brackets like that, you are going to miss out two terms in the multiplication and your answer will be incorrect. Now let's look at how we're going to multiply out these two brackets. Exactly the same method as we used in the last question. √3 multiplied by √3 gives us 3, minus one lot of √3, minus another lot of √3, minus 1 multiplied by -1 gives us +1. Tidying up, I've got 3 plus 1 gives me an answer of 4. Minus √3, take away another √3. Careful not to cancel these out, because what they do give you, in fact, is -2 √3. So we've expanded our brackets and written it in the form P plus Q root R as required. So the last thing we're going to look at when it comes to surds is rationalising the denominator. Now this is when we actually have a surd term on the denominator of a fraction. And when they want us to rationalise it, it means they want us to get rid of it. Here's a look at a slide and an example to show you how to do that. When we rationalise the denominator, we get rid of the square root on the bottom of the fraction. So for example, if we want to rationalise 2 over √5, we multiply the fraction by √5 over √5. That's because this is essentially multiplying the fraction by 1, so we're not changing the size. If we multiply 2 over √5 by √5 over √5, you can see that we then lose the square root sign on our denominator, as √5 times √5 gives us an answer of 5. Our numerator, 2 lots of √5, becomes 2 √5, as you can see there. Now it's always important, once you've multiplied, to simplify your fraction where possible. So now you've seen an example of how to rationalise the denominator, let's look at a couple of questions together. The first one we want to rationalise is this one here, 14 over √7. Now remember, the fraction you multiply by is always decided by what we have on the denominator in the question. In the previous one it was √5, here it's √7. So to rationalise this denominator, I simply multiply by √7 over √7. Square root of 7 multiplied by the square root of 7, remember, gives us the number 7, because the square root has now disappeared. And 14 multiplied by √7 gives us 14 √7. Now this is where I said it's important to check if you can simplify the fraction, as we can in this one. 14 over 7, or the 14 and the 7, simplify to 2 over 1. So our final answer would just be 2 √7, as the denominator has been rationalised and also simplified to 1. So if we take a look at our next example, it's going to involve multiplying out some brackets and simplifying before we rationalise the denominator. So the next question is √2 plus 1 multiplied by √2 minus 1 all over √11. Now when we multiply out, which we're going to do before we do anything else, remember how we multiply out and simplify our pair of brackets. √2 multiplied by √2 gives us 2. √2 minus 1 minus root 2, 1 multiplied by root 2, plus root 2, and plus 1 multiplied by minus 1 gives me minus 1. And that all, remember, is still over the square root of 11. Now, if we simplify the top before we rationalise the denominator, you see that this negative root 2 will cancel with this positive root 2, leaving us just with 2 subtract 1 on the top, giving us a final simplified answer of 1 over the square root of 11. So now we've simplified that, it's going to be easy for us to rationalise the denominator, because all we need to do now is multiply by the square root of 11 over the square root of 11, remembering that these two multiplied together will give us 11 as our new denominator, and 1 multiplied by root 11 we can just leave as root 11. So our simplified answer to that is the square root of 11 over 11.